Hello, dear 10th graders. Hope you are all doing well. Welcome back to your physics class. This is Mr. Idris, physics teacher. In a previous lesson, we studied temperature and heat section 1 in chapter 4, and we finished this section and we solved all questions related with the section 1 in chapter 4. Today's lesson, we are going to talk about change in temperature and phase in section 2, chapter 4. Change in temperature and phase. First of all, we have the definition of specific heat capacity, Cp. What is Cp, or what is the specific heat capacity? The quantity of heat required to rise an unit of mass homogeneous material 1 Kelvin or 1 Celsius in a specified way given constant pressure and volume at constant temperature and at constant pressure and volume. And mathematically, Cp is equal to what? Cp is equal to Q over mass and change temperature. And also you can define the specific heat capacity of the substance is equal to the amount of energy added, or the amount of the energy required per mass over mass and the change in temperature of the substance. So for example, guys, if we have 1 kilogram of water, 1 kilogram of water, okay, and if the temperature changes 1 Celsius, or the delta T for 1 kilogram of water is equal to 1 Celsius, from like 20 to 21 Celsius, or from 0 to 1 Celsius, the amount of the energy required to increase 1 Celsius of 1 kilogram of temperature is equal to about 4,186 joule. Okay, so if you replace into this equation, Cp is equal to what? The amount of energy. What is this? This is the amount of the added energy, or the amount of the energy being added to the substance. Which substance? Water. How many kilograms of 1 kilogram of substance in order to increase temperature in 1 Celsius? This is Cp. Okay, replace Q is equal to 4,186 per mass 1 kilogram, change temperature 1. So Cp is equal to what? Is equal to 4,186. Its unit is joule per kilogram Celsius. So this is very important, and you have to keep in your mind that the Cp is equal to 4,186 joule per kilogram Celsius. This is specific heat capacity of water. The specific heat capacity of water is equal to 4,186. What do I mean by this number? It means that the water requires 4,186 joule if we have 1 kilogram of water in order to increase 1 Celsius of temperature. According to this table, the Cp of copper is equal to 387 joule per kilogram Celsius. It means that the copper, if we have 1 kilogram of copper and increase the temperature from like 25 Celsius to 26 Celsius, one increases the temperature in 1 Celsius, how much energy is required? 387 energy joule requires to increase this temperature for 1 kilogram of copper. Specific heat capacity, guys, look, Cp, which is equal to Q, the amount of energy, per mass times delta T. What is Q? Energy transfer. Energy transfer as heat. Energy transfer as heat. Measured in what? Joules. M, mass of substance. Of substance. Delta T, change in temperature. For example, if the temperature of a piece of metal is equal to 20 Celsius before heating, after heating, what happens to the temperature of the metal? Increases. Like, for example, after heating, if the metal's temperature increases and is equal to 35 Celsius, what will be the change temperature? 35 minus 20, 15. The change in temperature is 15 Celsius. Measure it in Celsius, and mass measured in kilogram. Cp, what is Cp? The specific heat capacity measured in what? According, guys, how can you find and how can you know this? The unit of Cp, don't memorize. According this equation, Q measured in what? Joules. Mass measured in what? Kilogram. Delta T measured in what? Celsius. Okay, this is the unit of specific heat capacity. The units of CP, which is equal to joule per kilogram and Celsius. According to this equation, you can find out the unit and without memorizing, because you cannot memorize all the units. Only by the equation you can find out the unit of specific heat capacity, joule per kilogram Celsius. So what does specific heat capacity depend on? Cp is equal to Qm delta T. What does specific heat capacity depend on? Each substance has its own specific heat capacity, because the amount of energy required for the substance is different from one substance to another substance. Okay, for example, water requires more energy in order to increase temperature by 1 Celsius. Like copper requires less energy in order to increase temperature by 1 Celsius. So wood also different. Each substance has its own specific heat capacity. The specific heat capacity depends on one, the amount of energy as heat. More energy as heat, more specific heat capacity. Okay. With mass is inversely proportional. With temperature, also inversely proportional. Like for example, more mass, Cp is constant. Sorry, guys. Sorry. Cp for the substance is constant, but Q changes. Sorry. Cp is equal to what? Is equal to Q m delta T. Okay, and Q is equal to what? Q is equal to Cp m delta T. Cp is constant for each substance, but by increasing mass, the energy transfer as heat also increases. Okay, so which one has more energy required to increase temperature? 1 kilogram of water or 10 kilogram of water? Absolutely, the 10 kilogram of water requires more energy. More energy transfer as heat. Why? Because it has more mass. And the temperature increase also directly proportional with the Q. More change in temperature requires more energy as heat. But Cp is what? Is constant. Be careful. Cp is what? Cp is constant. Cp doesn't change. What does the energy transfer as heat of an object depend on? The energy transfer as heat depends on what? Specific heat capacity, mass, and change in temperature. Mass of an object, change in temperature, and specific heat capacity. What does specific heat capacity depend on? Mass of the object, change temperature, and energy as heat, and energy transfer as heat. Specific heat capacity measured in joule per kilogram Celsius. The equation for specific heat capacity applies to both substances that absorb energy or release. Okay, both of them. When the temperature increases or taken by the object, when the temperature increases, delta T and Q are taken to be positive. Okay, when temperature increases, increasing of temperature, delta T and Q are taken to be positive, which corresponds to what? Energy transfer into the substance. The energy transfer into what? The substance. When the energy is transferred into the substance, it means that the substance gains energy. When the substance gains energy, its temperature increases. When the temperature increases, T final is bigger than T initial, and delta T will be positive. And the amount of the energy added also is positive. Increasing of temperature, or like when the temperature increases, guys, look, when temperature increases, T final is bigger than T initial. Okay, it means that the substance or the object must be heated by increasing temperature. When T final is bigger than T initial, delta T is what? Is positive. When the object gains energy, okay, consider it to be positive. So Q is what? Is positive. Okay. What does the positive sign indicate for? What does the positive sign indicate for the Q? Energy absorbed. Okay. What is this? This is energy absorbed. Because energy is a scalar quantity, has no direction, but here in this case, positive and negative for Q, it means that release or absorb energy. Okay. But when temperature decreases, uh, T initial is bigger than T final. So delta T is negative, Q is also negative. Okay, when T initial is bigger than T final, it means that the object releases energy as heat. When the object or substance releases energy as heat, its temperature decreases. Okay, so in this case, delta T is negative and Q considered to be negative. So the negative sign for the Q indicates that the energy releases by the substance. Okay, energy transfer from the substance. So this table of the specific capacity for some substances, okay? For the students, only the specific capacity of water is required to know, okay? The CP of water is not given in the exam, so you have to keep in your mind and you have to memorize that CP of water is equal to 4,186 joule per kilogram Celsius. And also you can write what 4.186 times 10 to the power 3 is the same thing. What data do you need to measure specific capacity? Based on the equation, Cp is equal to Q over M delta T. What data do you need to determine the specific capacity of the substance? The amount of the energy transfer as heat, Q, mass of the substance, and change in temperature. Okay. When does delta T and Q are taken to be positive? When the substance absorbs energy. Okay. When the substance absorbs energy or gains energy as heat, its temperature increases, delta T is positive, and the amount of energy transfer as heat also is positive. And when does it taken to be negative? So in this question, we have two parts. The first part, Q and delta T is positive. When the temperature increases, okay, which corresponds to the energy transfer into the substance. But when the temperature decreases, delta T, Q are negative and energy transfer from the substance. It means that the substance releases energy as heat. What is calorimetry and can it be used for what? So what is the advantage of the calorimetry? At first, the calorimetry, an experimental procedure, as you can see here, this is the calorimetry. In calorimetry, the component of the calorimetry is the stirrer, thermometer, lead, water, and insulator outer container, and the test substance. So we have inner and outer container to keep the energy transfer from the surrounding and energy adding from the surrounding. So an experimental procedure used to measure the energy transfer from one substance to another as heat. Okay, it can be used to what? To measure the energy transfer as heat. Why is the water used in the calorimetry? Because water specific capacity has well-known value. Its value is known, and thus the change in the water's temperature can be used to determine the specific capacity as well. Determining specific capacity for the solving question. If a hot substance is placed in an insulated container of cool water, energy conservation requires that the energy substance gives up must equal the energy absorbed by the water. Look, so this is very important, guys. Look, if you have a piece of metal, okay, and a container of water, the temperature of water is equal to, for example, 20 Celsius. And the temperature of the metal is equal to, for example, 80 Celsius. If you put the metal into the water, does the energy transfer between these two substances? Absolutely yes. How? Which one release, which one absorb? The higher temperature always release energy and the lower temperature always absorb energy. So in this case, a metal, this one releases energy. As heat. Okay, but the water absorbs. This one absorbs energy. So in this case, temperature decreases when we put into the water because it releases energy. Delta T is negative, Q is also negative. But here the delta T increases, is positive, and Q also increases, is positive. Okay? So the higher temperature release energy and the lower temperature absorb energy. Okay, so we have energy transfer between, we have energy exchange between these two substances. But which one has more amount of energy transfer? That one has lower temperature when absorb energy or high temperature when release energy. Both have the same energy transfer as heat. Okay? For example, like Q absorbed by water. What is Q? The energy as heat. The energy, the gained energy or the absorbed energy as heat by the water is equal to the released energy by the metal. Okay? Released energy by metal. Okay? The amount of the energy absorbed by the cooler object is equal to the same amount of the energy that released by the hot object, which is metal. So this is called the conservation of energy. According to the conservation of energy, the gained energy is equal to the released energy. Energy absorbed by water is equal to energy released by substance. Okay? Now, according to this equation, Q absorbed is equal to Q release. Q absorbed is Q is equal to what? According from this equation, Cp is equal to what? Q over M delta T. If you rearrange this equation, Q is equal to what? Cp M delta T or mCp delta T, the same thing. Okay? mCp delta T. Now, instead of Q, write down what? mCp delta T for both cases. mCp delta T, mCp delta T. This one for absorb, and this one for what? For release. Guys, be careful. For the absorbed substance, for absorbed energy, the substance when absorbing energy, delta T is equal to what? This is just for make the question easy to understand. Okay, this is not scientifically. Be careful. Delta T is equal to what? T final minus T initial. For which one? For which substance? For the absorbing substance. For what? Absorbing substance. When substance absorbs energy, delta T is equal to what? T final minus T initial. But delta T is equal to T initial minus T final. This is for what? For released substance. For released substance. What do you mean by release? It means that for the substance which is releases energy. Okay? So if you go back to the previous page, look. Which one release, which one absorb? Absolutely, this one release and this one absorb. Why this one release? Because it has more temperature. So in this case, delta T is equal to what? T initial minus T final. Why? Because it releases energy. But for the cooler object, which is absorb energy, delta T is equal to what? T final minus T initial. So this is not scientifically, but in this way we can make the questions easier to understand for the students. Okay? Look, as I mentioned here, when substance absorb energy, delta T is equal to what? T final minus T initial. But when substance releases energy, delta T is equal to what? T initial minus T final. This is not scientifically. This is just for make the questions easy to understand. Okay? And final temperature, sometimes called the equilibrium temperature. Okay? Final temperature has the same temperature for both substances after a physical contact. For example, a piece of metal, if we put into a beaker of water, 80 Celsius, for example, 80 Celsius, and the water is 10 Celsius, for example. If you put into the water, this one release and this one absorb. Okay, after a physical contact, after a while, after all the energy released by the hotter object, okay, both substances reaches the same temperature. Okay, both substance reaches what? The same temperature. Now the temperature for both of them, for example, I guess is equal to like 30 Celsius, 30 Celsius. Okay, this is T final for metal, T final for water. The water, its temperature increases from 10 to 30 because it gains energy. But for the metal, releases energy, its temperature decreased from 80 to 30. Okay, but finally, T final is equal to 30 Celsius for both substance. For which substance? Both substance, always. Always after a physical contact, the final temperature is the equilibrium temperature? Yes. If the question asks us to find final temperature, this final temperature for both, okay, for both substances, they are equal. For example, water and the substance. Hot cools into the water, this one release, this one absorb, and after a while, they becomes thermal equilibrium. Sample problem 4b, look at this sample problem. Sample problem 4b, the question says a 0.05 kilogram metal bolt, so this is mass of the metal bolt, is heated to unknown initial temperature. It's then dropped into a calorimeter containing 0.15 kilogram of water. Guys, look, I highlighted both substances. So for solving this question, I suggest for you to make a table, okay? Make a table and you have to write down both substances, metal bolt, and water. So in this sample problem, how many substances do we have? 2, metal bolt and water. Mass, so you have to write down all the information about the metal bolt in this column and the other column for the water. 0.05 kilogram of metal bolt. So M is equal to 0.05 kilogram heated to unknown initial temperature. What do you mean by unknown initial? We don't know. Unknown initial temperature, it means that is not given. T initial is unknown. Is then dropped into calorimeter containing 0.15 kilogram of water. Mass of water, 0.15 kilogram. With an initial temperature of water, 21 Celsius. T initial of water is known, 21 Celsius. The bolt and the water, look, the bolt and the water then reaches final temperature, guys. This final temperature is the final temperature for both substances, okay? Because they are mixed together. T final, 25 Celsius. T final for the water also 25 Celsius, okay? Thermal equilibrium. If the metal specific heat capacity 899, Cp is equal to what for the metal? 899 joule kilogram Celsius, and for water it's constant. You have to memorize 4186 joule kilogram Celsius. Okay, so how many unknowns do we have? One unknown, the initial temperature of the metal bolt. According to the conservation of energy, the energy released by the hot substance, which is metal bolt, is equal to the same amount of the energy that absorbed by the water. According what? Conservation of energy. Q absorb is equal to Q release. But guys, first of all, you have to know which one release and which one absorb. So how do you know which one release and which one absorb? By initial temperature. Which one has more initial temperature? That one releases. Okay, but the substance that has low initial temperature, it means that this one absorbs. But in this case, we cannot compare with the initial temperature. Why? Because the initial temperature for the metal bolt was not given in this question. How can we know, and how do you know which one release and which one absorb if the initial temperature of one substance is not given? So you have to compare the water. Guys, the initial temperature of water is what? 21 Celsius. Final temperature is equal to what? 25. So what happens to the temperature of the water? Increase or decrease? Increase from 21 to 25. When the substance increases its temperature, it gains energy as heat or release? Absolutely it gains. Okay, why? Because when the substance gains energy as heat, its temperature increases. So because the temperature for the water increases, so that is why the water absorb and the metal bolt release. So this is very important. Okay, so which one absorb? Water. Which one release? Gold or the metal. So Q is equal to what? mCp delta T for water. mCp delta T for what? For metal bond. Okay? Because the water absorb energy, it's gonna be what? mCp T final minus T initial. Okay? Let's write down here. Guys, look. For the water, because absorb energy, it's gonna be what? mCp T final minus T initial is equal to, for the metal bond, mCp, because it released energy, it's gonna be T initial minus T final. Why here T final minus T initial? Because it absorbed. Why initial minus final here? Released. For released substance, always T initial minus T final, yes. Replace number, mass of water. Mass of water 0.15. 0.15. Cp water is constant 4186 times T final 25 minus 21. Mass of gold 0.05. Cp 899. T initial unknown. T initial unknown minus T final 25. Okay, so mathematically you can calculate by calculator. Guys, look. 25 minus 21, 4. 4 times 4,186 and times 0.15. I got 2,511.6 is equal to 0.05 times 899 is equal to 44.9, approximately 445. T initial minus 25. So open the bracket, multiply both terms, bring down 2,511. 45 times T initial, it's gonna be 45 T initial minus 45 times 25. I got 1,125. So rearrange the equation according math basic. Okay. Take this negative 1,120 to the other side. It's going to be positive 2,511.6 plus 1,125 is equal to 45 T initial. Okay, plus with this number 2,511.6, I got 36.6. 45 T initial. So T initial is equal to what? 3,636.6 divided by 45, which is equal to 80.8 or 81. Okay, I got 80.8 Celsius or 81 Celsius. This is the initial temperature of the metal ball, which is bigger than the temperature of the water. Okay, so in this way you can solve the questions related with the energy conservation between the two objects and the specific heat capacity and the energy transfer between the two substances. Practice 4B. Question 1. It is very easy. What is the final temperature? What is unknown? Final temperature. So at first you have to know how many substances do we have in this question. The first substance is gold bar and the second substance is water. Make a table. Okay. Gold and water. We have two substances. Okay. Final temperature is unknown for both of them. T final unknown. T final unknown, which is they have the same value. When 3 kilogram gold bar, mass of gold bar 3 kilogram, the first substance, initial temperature at 99 Celsius. Initial temperature 99 Celsius. is dropped into 0.22 kilogram of water. Mass of water is equal to what? 0.22 kilogram of water at 25 Celsius. T initial is equal to what? 25 Celsius. Okay. What is the final temperature for both substances? Both of them, they have the same final temperature. Okay. Cp of water is equal to what? Constant 4186 joule kilogram Celsius, and Cp for gold is equal to 129 joules per kilogram Celsius. Okay, so this is the information about the gold and the water. Okay, all the given value for both substances. Guys, which one release and which one absorb? Do we have the initial temperature for both substances? Yes. Which one has more initial temperature? The gold. So which one release? Gold release and the water absorb. How do you know? By initial temperature. More initial temperature, it means that releases. Less initial temperature, it means that absorb. Okay. According to the conservation of energy, Q absorb is equal to Q release. Which one absorb? Water. Which one release? Gold. Q is equal to what? Q is equal to mCp delta T. For what? For water. Because absorb. Q release also mCp delta T. But for which substance? For gold. Bring down M. Cp delta T is equal to what? For absorb? T final minus T initial. Bring down this mCp delta T for the gold. T initial minus T final. Why? Because it releases. Because it released. Okay. Now replace the number. This one is water, and this one the given value for the gold. Okay. Mass of water. Mass of water 0.22. Cp of water 4186. T final unknown, guys. T final unknown minus T initial of water 25 is equal to M for gold 3. Cp 129. T initial 99 minus T final also unknown. Okay. Use your calculator. 0.22 times 4186. I got 921 approximately. T final minus 25 is equal to 3 times 129. I think 387. 99 minus T final. Okay. Look. Open the bracket, multiply both terms. 921 times T final 921. T final minus 921 times 25, 23,025 is equal to 387 times 99, 38,313 minus 387 T final. Rearrange the equation T final with T final, number with number. So you have to move this number negative to other side and move the T final negative 387 T final to the other side. It's going to be positive. What does remain here? 921 T final. This is negative. It's going to be positive. 387 T final is equal to, bring down this number, 38,313. This is negative, it's going to be positive, 23,025. So look, 900, can we add this two terms? Yeah, because they have the same variable. Now we can add this two terms. 921 plus 387, 1,380 final is equal to what? 38,313 plus 23,025, 61,338. Rearrange the equation. T final is equal to what? 61,338 divided by 1,308 which is equal to 46.8 Celsius or 47 Celsius. The final temperature is equal to what? The final temperature is equal to 47 Celsius for both substances. Okay? This is question 1 in practice 4B. Guys, question 2, look at question 2. 0.225 kilogram sample of tin. This is the first substance, initially 97.5 Celsius, is dropped into 0.115 kilogram of water. How many substances do we have? 2. We have 2 substances, okay? Tin and water. The information of the tin that given in the question: mass 0.225 kilogram. Initial temperature of tin is equal to 97.5 Celsius, is dropped into 0.115 kilogram of water. Mass of water 0.115 kilogram of water at initial temperature 10 Celsius. 10 Celsius. The specific heat capacity of tin is 230 Cp, 230 joule kilogram Celsius, and Cp of water is constant, 4186 joule per kilogram Celsius. What is the final temperature? Exactly, this is the same question as we solved it in the previous question, question 1. T final is unknown. T final is unknown for the substance. Okay, so we have to do the same thing. Do we have initial temperature for both substances? Yes. Which one release? This one release. Why? Because it has more temperature. This one absorb. Why? Because it has less temperature. Okay. Q, guys, look. Q absorbed by water is equal to Q released by the tin. Q absorbed is equal to mCp delta T for water is equal to mCp delta T for what? For tin. Because the water absorbed delta T is going to be T final minus T initial. mCp. T final minus T initial. M14. Cp of tin. T initial minus T final. Why? Because it released. The tin is released energy. Okay. Now replace number. Replace number. Mass for water is equal to 0.115 times 4186. T final unknown minus T initial 10 is equal to mass of tin 0.225 times 230 times T initial 97.5 minus T final. So you have to multiply this to a number. After that, open the bracket. You have to do the same thing. Okay, you can find out T final, which is equal to something. Okay, it's very easy. Just you have to calculate very accurately by your calculator, and you will get the final answer. Question 3, guys, also the same question as question 2 and question 1. Okay, it's not necessary to solve this question, but I will give you some information. What is the final temperature? Also, final temperature is unknown. How many substances do we have? 2. Milk and coffee. Milk and coffee. Mass of milk 0.032. Initial temperature 11. 0.16 mass of coffee. Initial temperature is 91. Which one is hotter? Absolutely the coffee. Which one release? The coffee release and the milk absorb, because coffee has higher temperature. Assume that the specific heat capacity of the two liquids are the same as water. Both of them, they have the same specific heat capacity of water. Assume that the specific heat capacity of milk and coffee is equal to as the same specific heat capacity of water. And disregard energy transferred to another liquid. So it's very easy. You have to do the same thing and the same steps that I did in question 1 and question 2. Okay, guys. Question 4. This question is a little different with the other questions. Question 4 says a cup is made of, so the first substance is cup, okay, is made of an experimental material that can hold hot liquids. The The 0.75 kilogram of cup has an initial temperature 36.5 Celsius when it's submerged in 1.25 kilogram of water. So how many substances do we have? Two substances, cup and water. What is the mass of the cup? Is 0.75 kilogram. Initial temperature 36.5. When it's submerged in what? 1.25 kilogram of water. The second substance is water, which is equal to 1.25 kilogram. With an initial temperature of the water 20 Celsius. Guys, we have two initial temperatures for two substances. Which one release, which one absorb, and why? The higher temperature, initial temperature release, and the lower initial temperature absorb. So it's very important to know which one absorb and which one release, because without knowing this, you cannot solve the question. When it's submerged, okay, with initial temperature, what is the cup specific heat capacity? What is unknown? The specific heat capacity of the cup, and the specific heat capacity of the water is already known, which is equal to 4,186. You have to write down the equation. Q absorbed by water is equal to Q released by what? By cup. Okay? Q absorbed by water is equal to mCp delta T for water and mCp delta T for what? For cup. Okay? Because the water absorbed delta T is equal to T final minus T initial. Bring down this mCp T final minus T initial. This one also bring down for the cup, Cp for cup. Delta T is equal to what? T initial minus T final because it released. Okay? Mass of water given 1.25. Cp 4186. T final for water 24.4. Guys, sorry, I forgot to tell you the final temperature for the cup and the water. What is the cup specific capacity if the final temperature is equal to what? 24. This final temperature is the final temperature for cup or for water? For both. Why? Because they are mixed together. Okay? T final 24.4 minus T initial for water 20 is equal to mass of cup was given 0.75 times Cp unknown times T initial of cup 36.5 minus 24.4. Okay, you can calculate, guys. 1.25 times 4186 times open bracket 24.4 minus 20. I got 23,023 is equal to 36.5 minus 24.4 is equal to 12.1 times 0.57 is equal to 9. 9 what? 9 Cp. So Cp is equal to what? Rearrange the equation. 23 divide by 9. Divide by answer. I got 2,537 approximately. 2,537 joule kilogram Celsius. And sometimes you can write down 2.5 times 10 to the power 3 joule kilogram Celsius. This is the same thing exactly, just I changed it to the scientific notation and made as power. So in this way you can solve question 4 to determine what? The specific heat capacity. If the specific heat capacity is unknown in the question, mass for both substances must be given. Final temperature must be given. The initial temperature for both substances must be given. The mass for both substances must be given. Only the Cp is unknown, and you can rearrange the equation in order to determine the specific heat capacity. Question 5, guys, the table is wrong. Okay, this is brass and water. Question 5, exactly the same question as question 4. Okay, it's not necessary to solve, because just I will give you some brief about the question 5. We have two substances, brass and water. Mass of the brass and initial temperature, drop it into 2.8 kilogram of water. Initial, if the equilibrium temperature is equal to 6.8. This is equilibrium temperature. This is T final. What is this equilibrium temperature? T final. What is unknown? What is the specific heat capacity of the bros? The same thing, exactly the same thing. It's very easy. Okay, guys, question 6, it's a little different because this question is a mixed question between chapter 3 and chapter 4. The air temperature above coastal areas is profoundly influenced by the large specific heat capacity of water. How large the volume of air? What is unknown? The volume of air. Volume of air is equal to what? Because mass is equal, density is equal to mass per volume. Volume is equal to what? Mass of air divided by the density of air. Okay? How large the volume of air, volume is unknown, can cool by 1 Celsius, cooled by 1 Celsius, this is delta T. Cooled, the meaning of the cooled, it means that delta T, it means that change in temperature. 1 Celsius of energy is transferred as heat from the air to the water. How many substances do you have? 2, air and water. Thus increasing the temperature of 1 kilogram of water. So delta T for water also is equal to 1 kilogram. Okay, but we don't have mass of air, but we have mass of water. 1 kilogram of what? Of water. Change it by what? By 1 Celsius. Delta T for water, 1 Celsius. Delta T for air, also 1 Celsius. Okay, the specific heat capacity air approximately 1000 joule kilogram Celsius. For what? For air. Cp for air is equal to 1000. And the density of air approximately, density of air also is given 1.29. Density of air is 1.29. And the density of water is 1000 kilogram per meter cube. And the specific heat capacity also known for the water. So in this case, which one release and which one absorb? Absolutely, the water absorb and the air release. Okay, because the question says the air temperature of the gas is okay, and large specific heat capacity, how large volume can be cooled? Air is cooled. When because it's mentioned cool, it means that released. So which one released? Air released. Why? Because the question, the word of cool is mentioned in the question. Okay. So you have to already the question is solved with here. You have to equalize both Q for water and for air. For water, mass 1 kilogram. Cp 4180. Delta T 1 kilogram. 1 Celsius delta T. We don't have T initial and T final. Delta T is directly given. For the second substance, mass of mass for air unknown, Cp thousands, and delta T is 1. So in this way you can find mass of air. Mass, why? So the question asks you to find the volume of air, but you cannot find volume of air without mass of the air. So at first you have to find mass of air by using the conservation of energy transfer between the air and the water. Then you can find the volume of the air. Mass is equal to what? 4.86. Now we have mass 4.186 divided by the density of air 1.29. V of air is equal to 3.24 meter cube. Okay, so this is question 6. Very good question and very different question because 2 chapters are mixed in this question, and it is very easy. But at first you have to make the plan for solving this question. You have to write down this equation. After that you have to find M, then you can find the volume of air. Question number 7. A hot just minted copper coin is dropped in 108 gram of water. How many substances do we have? 2. Okay. The mass of the copper coin is 100 gram of water. Mass of water is equal to what? 101 grams. So you have to convert this gram to kilogram. Not allow solving question with gram. How can you convert gram to kilogram? Divide by what? Thousands. Divide by what? Thousands. Okay. So the mass of water is equal to what? 101 divided by thousands. I got 0.101. 0.101 kilogram. Okay. So the water temperature changes. What do you mean by water temperature change? It means that delta T. What is this? This is delta T. Delta T for water. This table is wrong. Guys, don't depend on this table. Now I'm going to make another table. We have a copper coin and water. So the mass of water was given in gram, 101 gram, which is equal to 0.101 kilogram. Convert to kilogram. And the water temperature change. What do you mean by temperature change? Temperature change, it means that delta T, we don't have initial and final, is equal to 8.39. Okay, 8.39. And the temperature of the coin changes by 68. For the coin, delta T is equal to what? 68 Celsius. Okay? And the temperature of change. What is the mass of the coin? What is unknown? Mass of coin. And the specific heat capacity of the coin must be given. Look at this table. The specific heat capacity of the coin. It should be given in the exam. Don't memorize. You have to looking for the copper coin. Okay, this is copper. 387. What is the specific heat capacity of the copper coin? Cp is equal to what? 387 joule kilogram Celsius. Cp of water, 4186 joule kilogram Celsius. Okay. This is question 7. Guys, look, this is question 7. Which one absorb and which one release? So which one has more change in temperature? The copper. So this one release. This one release, this one absorb. Q absorb is equal to Q release. Q absorb for water, mCp delta T. Which m? Mass of water. For release, mass of what? Copper. mCp delta T for the copper. What is unknown? Mass of copper. So you can rearrange directly the equation to determine mass of the copper. Mass of copper is equal to what we have with the mass of copper? Cp and delta T for copper. And m water, Cp water, delta T of water. Replace. Mass of water was given 0.101. Cp constant. Change temperature for water 8.39 divided by Cp for the copper coin 387 constant. Change temperature for the coin is equal to what? 68. Now mass is equal to what? By using your calculator, 0.101 times 4186 times 8.39 is it? I got 3,547 divided by what? 387 times 68. I got 26,316. 3,547 divided by answer. I got 0.135. 0.135 kilogram mass of copper. This is the mass of the copper, 0.134 or 35, it doesn't matter, okay? The last question, guys, the last question in this topic in section 2. The temperature of water at the highest point of Niagara Falls is 10 Celsius. Assume that this is Niagara Falls, okay? And this is the ground. This is the ground. The temperature of the water at the highest point, T initial is equal to what? 10 Celsius at the highest point of the Niagara Falls. That all potential energy of the water is transformed into what? Internal energy. Potential energy transformed into what? Into internal energy. Q, okay? And that each 4,186 joule kilogram leads to 1 Celsius. This is the specific heat capacity of the water, increases in the temperature of the water. If 505 kilogram of water, mass is equal to what? 505 kilogram of water. Fall distance of 50 meter. Falls, it means that height 50 meter. This is the height of the Niagara Falls is 50 meter. It's too tall, okay? One of the nicest place I have never seen, but I hope one day see the Niagara Falls in Canada. Fall distance 50 meters. What would be the temperature of the water at the bottom of the falls? At the bottom of the falls, T final is unknown. What is unknown? T final. T final is unknown, okay? While T initial at the highest point, 10 Celsius, known, okay? How can you determine delta T? Guys, look. Q is equal to what? mCp delta T, okay? If you rearrange, delta T is equal to what? But before writing this equation, you have to make your plan to solving this question. What is unknown? T final. Guys, look. Delta T is equal to what? T final minus T initial. Do we have T final? No, it's unknown. Do we have initial? Yes. Do we have delta T? No. So can we find delta T? Yes. How? By using this relation. Q is equal to mCp delta T. Delta T is equal to what? Is equal to Q over mCp of water. Delta T is equal to what? Q. Do we have Q? No. No, we don't have Q. But instead of Q, we have some extra information in order to determine Q. Guys, look. We don't have Q. How can we determine Q? The question says, assume that all potential energy of water converted into internal energy. It means that Q is equal to what? Is equal to gravitational potential energy. Whenever the question says all gravitational potential energy is converted into internal energy, it means that Q is equal to what? PEG. Q is equal to mgh. M, the amount of the water, 505. Gravity constant, height 50. So 505 times 9.81 times 50 is equal to 247,702. 0.5 joules. This is Q. Now you can replace here. Okay. Delta T is equal to what? Q we didn't have, but we found. Divided by mass, 505 Cp 4186. Delta T is equal to what? Delta T is equal to 0.1 Celsius. 0.1 Celsius. What is this? This is delta T. This is not the answer of the question. This is delta T. Replace into this equation. Guys, look. Delta T is equal to what? T final minus T initial. T final is equal to what? Delta T plus T initial. T final is equal to delta T. We didn't have, but we found 0.1 plus T initial 10 Celsius, which is equal to 10.1 Celsius. 10.1 Celsius. This is the final temperature whenever the water falls or reaches the bottom of the Niagara Falls. So if 505 kilogram of water has 10 Celsius at the highest point of the Niagara Falls, what happens to their temperature if the 505 kilogram of water reaches or landed to the bottom of the Niagara Falls? Its temperature increases because of this gravitational energy. Gravitational potential energy is converted into internal energy, and this amount of increasing of temperature is equal to 0.1 Celsius. So the final temperature becomes what? 10.1 Celsius. At highest point, the temperature 10 Celsius for the water, but at the lowest point, usually the water has more temperature. Why? Because of this falling down. That's all for today. Thank you for listening. Inshallah, in the next lesson, we will explain the latent heat and we will solve all questions related with the latent heat. Keep up your visiting and thank you for listening.